today's video, we are going to create an application of servo motor and coin acceptor. So we will create a new project by clicking this icon. This is a standalone project, so we will click next. This time we are going to use the PIC 16 F1508, which is PIC 16 F1508. This IC. So this IC has 20 pins and it is smaller than the PIC 16 F18875. So we will click next. For the supported debug header, choose none. Then click next. So we will choose ECE8 for our compiler. And lastly, we will name this project as Summative 4. Let's make it Summative 4 2. So there. It means that Summative 4 version 2. So we will click Finish. As we can see, when our project is made, new folders arise or new folders are created. So we will click our MCC for creating our settings for the oscillator's input and output pins. So we will click Save and we will change the package view to PDIP20 since we use a dual inline package type of IC. So let's first head to the internal oscillator. So we will set our oscillator to internal oscillator IO function on clock in pin. So we are not going to change that. Then for our system clock select, we will use the frequency oscillator, which is set by default, but our internal clock should be set by 2 megahertz. So as we can see, our current clock runs on 2 megahertz. And our watchdog timer is disabled and the low voltage programming is enabled. So we are going to select our peripherals first. So we will choose the PWM, which is PWM4, and the timer, which is the timer 2. So first we will set our timer 2. So we will enable our timer and we will set, as we can see, the timer period is around 512, runs about up to 512 microseconds. But for this servo, we need at least 20 milliseconds. So we will change our prescaler to 1 is to 164, which it can handle up to 332.768 milliseconds. So we will change this to 20 milliseconds. So as you can see, our actual period is 9.968 milliseconds, which is roughly 20 milliseconds. So we'll proceed to our PWM signal, which is here. We will enable our pin output, which as we can see, it is set on PWM4, which is the pin 15. So we will set our duty cycle to 50% and the PWM polarity to active high. So now we will proceed to our pin module. So for this one, we will uncheck the analog since it is a digital output, and we will add another types of inputs and outputs for our coin and for our LEDs. So first one, we will set our input to the coin. We will rename it as coin. So our coin acceptor is connected to pin 11. Next is we're going to add our output pins, which is the two LEDs. For this one, we will uncheck the analog again, and we will name it as LED1 and LED2. So this is the pin module, or this is the setup that we're going to use for our project. Since everything is set, so we will proceed by generating this code. So we will click generate. So as we can see, it's still generating, and now the generation is complete, so we can proceed to our main.c. We will go to source file and main.c. So as we can see, this is where our workspace, or we will put our code. So first, we are going to create an if else statement. So if, let's type our formats first, and then else. So there. So for the if statement, if coin get value is equals to 0, so it means that if the coin acceptor send a pulse, so this means this project will only use 1 peso coin. So we will load our PWM signal. For the code, we will proceed it here. So we will copy and paste it to avoid typographical errors. So there, and back to our main.c. So we will change this inside the parenthesis is our duty value of our PWM signal or output. So this means that we will set it to 65. So since, as we can see, by computing its duty cycle and its equivalent PWM DC value for the servo motor, it ranges from 30 to 65 respectively, 30 to 65, where 65 is the 90 negative 90 degrees, while the 30 is the positive 90 degrees, where the 65 is the positive 90 degrees, while the 30 is the negative 90 degrees. So we will code our indicators now. So LED 1 should be set high. Then LED 2 was off or set low. And we can have the delay of 1 second. This means that the all that the PWM signal also set to 1 second delay. So it will be in the state of 65, or it will load the duty value of 65 for around 1 second. Then we will turn off our LED 1. So this is the code for the if. And for the else statement, we will set our LED 2 to high. Then LED 1 to low. And lastly, for our PWM signal, but this time it has the value of 30. There. So as we can see, this is the code needed. So this will create, when the coin is inserted, it will load the PWM signal with the duty value of 65. The LED will turn one will turn on, but the LED 2 will turn off for around 1 second, and LED 1 will turn off. Else, if coin is not detected, the LED 2 will set high, the LED 1 will set low or turn off, and the PWM signal will load the duty value of 30. So this is the code that we need. So we can build this one by clicking this icon. So it's building, and as we can see, no errors occur, and it can be loaded to our IC for the demonstration of this project. the code is already uploaded, and this is the setup for testing our IC, or test or creating our prototype. As we can see, the servo motor is powered on 5 volts, and its signal wire is connected to pin 15. The coin acceptor is connected to the pin 11 with the pull-up resistor to avoid damaging our IC, and LED 1 is connected to pin 8, and LED 2 is connected to pin 9. So we are going to test our circuit. So first, we will use the old edition, which is this one. As we can see, it flips on the other side, and the green LED lit up. Let's try this time the new edition of the first peso coin. Uh, this this prototype, or this demonstration, only use 1 peso coin. So let's insert the coin. There, it flips on the other side, and the green LED lit up. So let's try some various coins with different versions, mix of old and new. So this is the new one. It flips on the other side for a few seconds, and it turns back to its normal position. Let's try one more time. There, green LED lit up, then flips on the other side. Another one. Another one. Next one. And last one. There. So as we can see, our prototype acts like a vending machine. So if it detects that there is a coin inserted, it opens the door and the item will fall out, and the indicator indicates that there is a coin inserted, and for a few seconds it will close, and it will back to its normal state where the coin is not yet inserted. So this is the prototype for our for this project. Hope you like it, which is the application of the coin acceptor and the servo motor. Before we go, let's try one more time. And hope you like this video, and see you again next time.